All right, so today it is 10/20/21. So what we want to do is reduce roots. When I say roots, we're talking about square roots. We're talking about cube roots. We're talking about all of them. We're talking about square roots and cube roots and maybe even fourth roots sometimes. We're going to simplify them. We're going to make them easier, okay? We'll make them smaller. Okay? We're going to make them easier. We're going to simplify them, okay? Square roots, cube roots, fourth roots, all those. So these problems are too big. That's what we're doing. They're too big, we're making them smaller. Does that make sense? We can make them smaller, they're easier to work with. So in example 1, go ahead. Go ahead, Victor, make it quick. So in example 1, it's a cube root. So then the question is, what times what makes 54? But you've got to look at these numbers. These are the perfect ones. These are the ones we want. So what times what makes 54? Look at these numbers. Do you see a number here that would work?
Nope.
Anybody? 27. So I think, in fact, I'm not sure I could use a calculator, but I think 54 divided by 27. 54 divided by 27 is, hold on, I'll try it again. 54 divided by 27 is 2. So I'm going to have the cube root of 27 and the cube root of 2. All right? And I chose 27 because it's a perfect cubed, and I know the cube root of 27 is 3. Same stuff, just bigger numbers. Okay, except for their cubes. Okay, so the cube root of 27 is 3 times the cube root of 2. Now, I was helping Leslie this morning, and we went through this whole thing of why we keep this. So, real quick, I want you to see this. So, watch. So we got this ugly decimal. You guys see this? This ugly decimal or this number. This number looks nicer, doesn't it? That's why we leave this number. We can't take a cube root of it, but we don't want the decimal of it, okay? Okay, example 2. 48, but it's a fourth root. So I look. Which one of these numbers should we use that goes into 48? What number? 16. Does that make sense? So I think it's 16 times 3. So I'm going to do the fourth root of 16 and the fourth root of 3. And I never put those down, but I can put those down real quickly because, you know. So this was a 2, a 3, a 4, and a 5. So what is then the fourth root of 16? What's the fourth root of 16? It's 2, isn't it? So I'm going to go 2 times the fourth root of 3. Now the fourth root of 3 is an ugly decimal. We don't want an ugly decimal. We don't want this number here. We don't want fourth root of 3 or this ugly decimal. No, I don't want the ugly decimal. So I'm just going to leave it as the fourth root of 3, okay? Number 3. All right, well, I've got some fractions going on here, so maybe I can reduce it a little bit. So I might be able to reduce it. 6 and 40 might reduce to 3 and 20, right? So I'll make it the cube root of 3 over the cube root of 20, okay? Do I want to do it that way? Yeah, I think that's the only way I can do it. Oh, no, I want to do it a different way. I want to do it a different way. I do. So I want to do it a different way. Cube root of 6, and I want to go to the cube root of 8 times the cube root of 5, right? Why do I want 8? Yeah, it's 2. That's a 2, isn't that 2? Cube root of 8, cube root of 8, cube root of 8 is 2. So I'm going to write cube root of 6 over 2 times the cube root of 5. And I'm going to come back to this one, okay? Come back to it, okay?
Oh, no, then.
Nope, but I'm going to come back to it, okay? Okay, example 4. Fourth root of 162. 162, 162, fourth root, 162. Do you see a number that would help with 162? Fourth root. What about 81? 81 and 162. So I'm going to go the fourth root of 10. I'm going to go the fourth root of 81 and the fourth root of 2. All right? What's the fourth root of 81? Well, let's check. Fourth root of 81 is 3, right? 3. So I'm going to have the fourth root of 10 over 3 times the fourth root of 2. And we'll come back to this one. Molly. What did I do? Come show me. What did I do, Molly?
You missed number 4 on the not to number 5, but you missed number 4.
Oh, I didn't do the fourth on this one. Oh yeah, that should be a 5. What is the fourth root of 4? Is it 216? I'll bet it's 216. 4 to the 4. Thanks, Molly. 256 is 4, and that's 5. Molly, thank you. I did make a mistake. All right, now, example 5. We did this last year. Watch. And I don't know if you guys remember it last year, but watch. Okay? We did this last year. I know last year was just a lost year. I was last year. But we learned last year that you can't have squares at the bottom, right? Right? Remember that? But if you get the plus or minus, we're going to multiply by its opposite. It's called the conjugate. It's opposite. We're going to multiply top and bottom by 3 minus square root of 3 minus 2. Okay? Always by the opposite. You have plus or minus. Okay? I'll show you. We did this last year. I don't know if you remembered it.
It's coming back.
It's coming back. This is hard because I'm teaching last year's. I'm teaching all last year. Algebra, geometry, and algebra 2. All every day. It's tough. So I multiply by a thing called the conjugate, which is this. Okay, I'm going to multiply by the square root of 3 minus 2. Top and bottom. Okay? It's called the conjugate. It's the opposite. And I'm going to multiply, okay? I'm going to get, that times that, so I'm going to get a 5 square root of 3 minus 10 over, I'm going to multiply. I'm going to get the square root of 9 minus 2 square roots of 3 plus 2 square roots of 3 minus 4. We did this last year, so all we're doing is geometry stuff right now. When we do the conjugate, these two cancel, and I see something easy. And that's the square root of 9, which is 3, right? So let's see what's left. 5 square roots of 3 minus 10, and 3 minus 4 is a negative 1. Sorry, so here, I'll rewrite it here. 5 square roots of 3 minus 10 over negative 1. So there's no longer a square root in the denominator. We're getting there. We are getting there. You guys ready to turn the page? And then I'll cut you loose to go get blood pressure. Okay, example 6. Same thing. We're going to multiply by the conjugate. Opposite of this. Square root of 5 minus square root of 3 and square root of 5 minus square root of 3. The opposite, called the conjugate. And I'm going to multiply. All right? I'll go this times this, this times this. 3 square roots of 5 minus 3 square roots of 3. That's what that is. And on the bottom, I get the square root of 25 minus a square root of 15 plus a square root of 15 minus a square root of 9. Okay? Now, let's see. What do I got? Well, these two cancel, don't they? boom, boom. And I know what that is, and I know what that is, right? So I'm going to have a 5 and a minus 3, which is 2 on the bottom. No more square roots on the top. And then I'll have 3 squared is 5 minus 3 squared is 3. Almost done. It's a bummer because we should have learned this last year, but we're just going to make it. Okay, now, last problem. Cannot subtract them yet. Not yet. Cannot subtract them, not yet. But maybe we can change this into a square root of 3, or into a cube root of 3. So I look for my cube roots. Look for my cube roots. And I'm looking for something times something that's going to make 375. So which one of these numbers looks like the right number, maybe? 125? Yeah, so let's check it out. I'm not sure what it is. If I just go, 375 divided by 125, and I get, it goes in evenly, 3. So I can do this. So I'm going to rewrite this as the cube root, 125, cube root of 3. I know that this becomes a 5 times a 5, because that's a 5, right? Whole number 5 and 5 times 5, those are whole numbers. That's 25. Those are both whole numbers. 5 times 5. 25 cube roots of 3. And now I can subtract them. They're the same. 3 minus 25 makes a negative 22 of these. Negative 22 cube roots of 3. Okay, that's what I have. Let me pass the homework out to you. And then if you need to go get blood pressure tested, you can. I might even go